Hello parents, we have created a brief video to show you the addition and subtraction strategies that your child has been exposed to in second grade. We are hoping that this will help you, as we are very familiar with kind of our traditional math strategies that we learned from when we were back in school, and we're not always familiar with what they're learning in second grade. So these are optional strategies for your child to use. It is okay if they use a different strategy. Maybe you have taught your child some of that traditional math that we learned, and that's fine too if your child seems to understand that. What we aim to focus on is helping our children grow as mental math thinkers, and really using mental math to help them solve equations in addition and subtraction. So that is our ultimate goal. So let's go ahead and get started with this addition strategies. What I'm going to do is use this equation, 25 plus 17, for all of my examples. So let's start with base 10 blocks. What the student would do to solve 25 plus 17 is they would go ahead and draw those two amounts in base 10 blocks. So I would draw 10, 20, 21, 22, 23, 24, 25, plus 17, 110, 1, 2, 3, 4, 5, 6, 7. So hopefully students will realize that there are more than 10 ones here. If we have more than 10 ones, we can go ahead and trade them in for 110. It just makes the counting easier. So I have 7 ones here, and then over here I have 8, 9, 10. So I can trade those 10 ones in for a 10. And so now it's a little bit easier for me to count. And so I have, starting with my 10s, 10, 20, 30, 40. And then I need to count my leftover ones, 41, 42. So this is a great strategy, especially for students who benefit from really drawing and being able to count what they drew and count the base 10 blocks. So moving on to number line, what we would do is start with our largest number, which is 25. And then what we've encouraged students to do is think about breaking down the number 17 is the same as 10 plus 7, so that they know there's 1, 10, and 17. So we would drew on our number line 1 hop of 10. 25 plus 10 is 35. We always land or write the number we land on. And then some students might go ahead and just say, okay, and then I have to add the 7 plus 7. And they might be able to add that easily we would land on 42, And that is great. If your child can go ahead and do that and figure out, that's wonderful. That's a very efficient way, obviously. If they have trouble maybe adding that 35 plus 7, here's another way to think about breaking it down. So again, 25 plus that 10, and we land on 35. Then if they maybe struggle with adding that 7, another thing to think about is taking this 7 and breaking it down to 5 plus 2, because it's a little bit easier for students to add that 5, and 35 plus 5 is 40. We really encourage students to work with friendly numbers. What that means is a number that ends in 0, or even numbers that end in 5 are a little bit easier for students to work with. So now from that 40, I just have to add on this 2, and 40 plus 2 is 42. So either one of those are very efficient ways to solve it using the number line. Obviously, the less hops on the number line, the better. So decomposing is maybe a strategy you're not as familiar with. This is especially for students who maybe don't want to draw all those pictures and prefer to do a little bit more mental math, so this is a great strategy. What I'm going to do is I'm going to write the equation again, 25 plus 17. And we're going to break down each number by tens and ones. So 25 has two tens, which is 20 plus 5, and 17 becomes 10 plus 7. So the first thing I'm going to do is add my tens. I'm going to write it over here. 20 plus 10 equals 30. And then I have my ones, so I'm going to do underneath it 5 plus 7 equals 12. Now, this might be a place where students get a little stuck, right? Because now we need to add that amount, 30 plus 12. Your child might be able to go ahead and add 30 plus 12, and that's great. If they struggle, though, again, we encourage them to think about the number 12 is the same as 10 plus 2, which makes it a little bit easier to think, oh, okay, now I'm adding tens again. 30 plus 10 equals 40, and then 40 plus 2 equals 42. Again, students don't need to do all of those steps. I wanted you to see my thinking, and especially if students get stuck here, what they can do to make the process easier, because we don't want them to sit there necessarily and count 30 and add 12 on their fingers. How can we do that more with mental math? So again, adding on 10 and then 2 is a lot easier. Okay, so those are the typical addition strategies that we have been practicing in class. Let's take a look at subtraction. Now, to begin, I want to show you, I used obviously the same numbers here. Now I have 42 minus 17. I did this on purpose because when you think about the number, the equation 42 minus 17, this is what we would refer to as a problem where we need to borrow, right? Because I don't have enough ones to take 7 away from 2. And this is always usually a little bit more of a challenging problem for our students. In fact, I refer to it as an uh-oh problem. Uh-oh, I don't have enough ones. What do I do? So we're going to kind of show how these strategies help students, especially with subtraction, especially when we need to borrow. So you'll kind of see how that works. So let's start with base 10 blocks. Again, with subtraction, I'm going to just draw the largest number, which is 42, 10, 20, 30, 40, 41, 42. And then we need to subtract 17 from that 42. This is a great visual for students to see, oh, okay, I can take 10 away, but uh-oh, I cannot take 7 ones away from the 2 ones. I don't have enough ones. So before we can do any subtraction, we need to borrow. And I'm going to borrow from my tens. So I'm going to take away a 10 and I'm going to change it into 10 ones. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we can subtract 17. I have enough tens and I have enough ones. So now I'm going to go ahead and take away a 10. There's 1 10 in 17, and take away my 7 ones. 1, 2, 3, 4, 5, 6, 7. So now students just need to make sure they carefully count everything that is not crossed out, right? So I am left with 2 tens, so 20, 21, 22, 23, 24, 25, 5 ones. So I'm left with 25. So that's a great visual for students who need to understand really what it means to borrow and taking away a 10 and turning it into 10 ones. So on the number line, very similar, of course, we are going to go ahead and start now on this end with the largest number. I'm going to start with 42 because we're going to be traveling this way, right? Because if we're subtracting, our numbers are going to get smaller. All right, so I'm going to start with 42, And again, thinking about that number 17, I can think about it as it's the same as 10 plus 7. That helps me know that I need to take away 1 hop of 10 and then 1 hop of 7. So, of course, we can do our minus 10 and land on 32. And then some students, of course, can just figure out then the minus 7 and land on 25. Some students, however, have a little trouble with that. So I'm going to go ahead and back up and talk about what our next steps could be if they can't just do it in the 2 hops. So again, thinking about the next step is to think about breaking down that 7, right? Which we said is the same as 5 plus 2. So one option is to do that minus 10 minus 2, because 32 minus 2 can get me to that nice friendly number. It's a good number to work with. And then my minus 5 and get to 25. Okay, so that is a very efficient way to subtract 17 from 42. Another option could be starting with that 42 and maybe kind of go backwards. This time I'm going to subtract the minus 2 right away because I can see 42 minus 2 gets me out to a nice friendly number of 40. And then maybe minus that 5 and get to 35. And then my minus 10 to 25. So again, either way works. They're both very efficient ways. We actually encourage our students to try to think of more than one way to solve this equation on a number line, right? It really helps them understand that either way works. You can see both ways were done with 3 hops. So now this very last one is subtracting in pieces. So while over here with addition, we had decomposing, well, we don't do decomposing with addition. A strategy that we like to use is subtracting in pieces. This is one that your child has not necessarily been exposed to much yet, but it is another great way, especially if they don't want to do the pictures and again prefer a little bit more of that mental math. So subtracting in pieces, I'm going to write my equation vertically this time. I'm going to do 42 minus 17. And what I'm going to go ahead and do is I'm going to circle my largest number, my number on top, and the number in the tens place below it. So I circled the 10 and obviously not the 7. So now over to the side, I'm going to subtract those numbers. So 42 minus that 10. Of course, I'm not writing 42 minus 1 because it is the number in the tens place. That represents a 10. 42 minus 10 equals 32. Then below it, I'm going to take that answer. 32 minus this guy, right, minus the 7. Now, again, this might be a place where a student gets stuck. 32 minus 7 is not necessarily easy for them. If they can solve that, awesome. If not, this would be a place where I think, I'm going to break down that 7. So I'm going to go ahead and think of the 7 again as 5 plus 2, right? And so now it's a little easier for me to think, okay, so I'm going to move over here. 32 minus 2 equals 30, right? Getting to that friendly number is so much easier to work with. And then I'll take 30 minus the other number here. I've got the 5 equals 25. All right, so that is subtracting in pieces. So now you have seen our addition and subtraction strategies, and we hope that this will help you better understand the strategies that your child has been exposed to in 2nd grade. We do not expect you to be an expert. We just simply want you to feel more comfortable and more confident with these strategies if you want to help your child at home. We hope that you found this helpful. As always, if you have any questions, you can contact your child's teacher. Thank you so much.